So in 18.2 right now, we discuss about the stage 1 of catabolism, where we discussed breaking larger molecules into smaller molecules. Food undergoes digestion in stage 1 of catabolism. The process converts large molecules to small molecules that can be absorbed in the body. So we'll see how this works. We'll start with carbohydrates, and in the previous PowerPoint 18.1, we had discussed carbohydrates, proteins, and fats. So we'll take one at a time. Carbohydrates. So enzyme produced, where does the breakdown of this carbohydrate molecule start? It starts in the mouth. So enzymes produced in the salivary glands in the mouth hydrolyze some of the alpha glycosidic bonds in amylose and amylopectin. And these are not new terms for us. We have discussed alpha glycosidic bond in amylose and amylopectin. So in the mouth, the enzymes produced in salivary glands hydrolyze some of these alpha glycosidic bonds, producing smaller polysaccharides as maltose, glucose, dextrins. So these big molecules are broken down into these smaller. So dextrins are 3 to 8 glucose units long. So after being swallowed, the partially digested starch entered the acidic environment of the stomach, where the low pH stops carbohydrate digestion. So nothing happens in the stomach because of the low pH, high acidic value of the pH, nothing happens. So food passes through the stomach into the small intestine, which has a pH of about 8. So it's slightly basic now. So the enzymes produced in the small intestine, the enzyme produced in the pancreas are available in the small intestine to hydrolyze the remaining dextrins to maltose and glucose. Maltose is a 2-unit disaccharide. Glucose is a monosaccharide. And we know dextrins are 3 to 8. So the 3 to 8 are broken down into 2 or 1. So now enzymes produced in the mucosal cells that line the small intestine hydrolyze even maltose, lactose, sucrose into monosaccharides. So the idea is to break down the carbohydrate into monosaccharides. The monosaccharides are then absorbed through the intestinal wall to the bloodstream and carried to the liver, where any fructose and galactose are converted to glucose. So in the digestion of carbohydrates, the end product is glucose. So if they get if fructose and galactose are produced, they are converted isomerization into glucose. So this is the chart of what we discussed. In the mouth, the polysaccharides use the salivary amylase to break down into dextrins, maltose, glucose, cross through the stomach, come into the small intestine, where the amylase, the pancreatic amylase, there is the salivary amylase, pancreatic amylase, all these are enzymes. End product is glucose going through the bloodstream into the cells. So now we'll talk about lipids and proteins. So fats and lipids. So fats and lipids are triglycerols. So where does the digestion of fats and lipids start? It starts in the small intestine, where bile salts break fat globules into smaller particles called micelles. So it starts in the small intestine. So what happens there? The bile salts break fat globules into smaller particles called micelles. This is called the process of emulsification. So this is a triglycerol. This is the fat. This is the large molecule. And this molecule is going to be broken down into smaller molecules. So we see that the triglycerols are hydrolyzed in the small intestine into monoglycerols and fatty acids. They come through the intestinal wall, reconnect into triglycerol, connect to a protein, and form a component called chylomicrons. And through this, transport themselves to the lymphatic stream, bloodstream cells, and then break down into glycerol and fatty acids. So this protein connection gives them the mobility or the vehicle to pass through the lymphatic system, bloodstream into the cells. And there they break down into glycerol and fatty acids. And the chylomicron is an important component. Combining with protein, it uses that as a vehicle, the protein as a vehicle of transport. So this is what happens with fats, lipids, triglycerols. Now, when it comes to proteins, the digestion of proteins begins in the stomach, where the pH is 2 and the high acid pH, acidity in the stomach, the pH being very low, it's a very strong acid, acidic environment, and it denatures the proteins. So if we go back to the proteins, we know that denaturation happens. One of the pathways to denaturation is acids. So it denatures the protein and activates enzymes such as pepsin to hydrolyze peptide bonds. Now, this moves out of stomach into the small intestine, where trypsin and chymotrypsin hydrolyze the polypeptides to amino acids. And in the end, amino acids are absorbed through the intestinal wall and enter the bloodstream for transport to the cells. So this is the path the protein takes, beginning in the stomach. So again here, this is a graph, again proteins, pepsin, polypeptides in the stomach, small intestine, trypsin, chymotrypsin into amino acids, going through the intestinal wall, bloodstream into the cells. Match then products of digestion of amino acid, fats and glycerol and glucose with the types of food. Carbohydrates break down to glucose, proteins into amino acids, fats into fatty acids and glycerol. So this is the stage 1 of catabolic processes.